This one looks like it's going to be a fun one. This is the integral of a rational function. It's proper, so there's no division involved. The degree of the top is exactly one less than the bottom. So, whenever I see a problem like that, a rational function who's with those degrees, I'm thinking right away u prime over u, or using natural logs. So the first thing I would attempt to think about is what's the derivative of the bottom? And the derivative of the bottom is 2x plus 10. So it's not exact. Um, the top is 2x plus 3. So it's not a straight natural log. Another thing I notice about this is it looks like it could be an arctan as well if we complete the square. Because if we complete the square, I think we can make the bottom u squared plus a squared, which would be an arctan. However, the top is kind of not good for that because that 2x is in the way. That would be a nice arctan problem. So really what it comes down to is we kind of have a combination of both. We have a it's close to being a u prime over u, or a natural log, and it's also close to being a arctan, but not exactly for either. So one strategy for this is make it a u prime over u, and then see what we can do with the leftover. Hopefully it will be the arctan. So here's how. I was thinking that the derivative of the bottom was 2x plus 10. That meant if the top was exactly 2x plus 10, it would be u prime over u. So what I'm going to do is I'm going to make it exactly 2x plus 10. And that's easy to do. You just add 7 to the top. Now, you can't do that, but you can add 0 to the top. So if you add 7, if you just subtract 7, that would be like adding 0. So it's almost like when we were doing with multiplication. If you multiply something on the top, you can even it out by multiplying the same thing on the bottom. But if you add something on the top to even it out, you have to resubtract it from the top. So you're adding 0, just like that. So you can see that this is exactly the same as this. So now when we rewrite this thing, it's going to be 2x plus 10, which is exactly what I would need for a u prime over u situation. And then I also have a minus 7. So now I can use the fact that I can split this fraction up as long as I keep the denominator intact. So here's the first part of the split up, and this is the u prime over u part I need, and then minus integral of 7 times over this, which is hopefully the arctan function that I need. As long as this completing the square on the bottom becomes u squared plus a squared, that will be a pretty easy arctan. So that's what we're going to focus on right now. The first integral is u prime over u. So I'm done with that one. This is u prime over u exactly. So that's going to be the natural log of the bottom. The second one, I'm going to use my completing the square. So a is 1, so this is a pretty straightforward completing the square. B is 10, as I just wrote. So you add b over 2 squared. 10 over 2 is 5. 5 squared is 25. Subtract 25, so you're not changing anything. And then there's a plus 26. So this is looking great. This would be x plus 5 quantity squared. Negative 25 plus 26 is plus 1. Now, if this turned out to be minus, in other words, if that 26 was something less, like 24 or 23, then arctan would not apply and we'd be in trouble. But as long as this is a plus and this u squared plus a squared, we are very good to go. Whoa. So let's just copy this down one more time. No, let's do this. I was going to recopy it, but I'm not going to. So we have 2x plus 10 over x squared plus 10x plus 26. I could have integrated that right now, but I'm going to wait till I integrate this one. Okay, so now on the second integral, this one, u is x plus 5, du is dx. So that's a straightforward substitution. A is 1. That's great. So this is an arctan because it's a squared plus u squared. So I think I'm ready to integrate. First one's the natural log of the bottom. It was u prime over u. I did that. I made sure it was. Second one, the constant is a 7. It's a straight arctan, as we can see with all these substitutions. So the formula for arctan is 1 over a. A is 1, so that's 1, times the arctan of u over a. U is x plus 5, a is 1. So I think we are done. That's all there is. Oh, plus c. Don't forget that. And that's that. Let's see what Wolfram had to say about this one. I think this one turned out to be pretty straightforward, so I think we should have a match. X squared plus 10x plus 26 minus 7 arctan of x plus 5. Yes, that is it. So it wasn't too bad after you just saw that technique, and now that you see it, you can apply it to any other problem you come across with. So thanks for watching.